Let's discuss another lesson, system of particles and rotational motion. So in this we are about to discuss about system of particles, how these particles will be there. So generally in any object it is made up of particles. So here is also we are considering only the particles to say about system. I mean to say about any object we are considering about the particles. Okay, for example let's consider one block. So in this block what will be their particles are there. Similarly if you will consider one circle, so here is also one ball. If you consider now, this is also made up of particles. So if you will take one triangle solid, then it is also made up of particles. All particles are presented. So these particles are have one center, that will be called as center of mass. Okay, that's what we are going to discuss now. So what is meant by center of mass? Okay, center of mass. What you are thinking about center of mass? So center of mass of a body, for example let's consider one circle body, spherical body. Okay, so see, I will tell the definition first. So center of mass of a body or a system where the entire mass of this body is concentrated. To describe, it's a translatory motion or rotatory motion. Most probably it will be in translatory motion only, straight line. Okay, right. So total mass where it is supposed to be concentrated, that will be called as center of mass. Okay, for example let's consider on surface here. Here is a ball. So let's consider three particles A, B and C. When it is rolls to this point, this will be the point, this will be the point, this will be the point. So A, B, C. So A in between B, bottom C. So A in between B, bottom C. Now again it will roll still. Then what will happen? The bottom will comes to A, middle will be B, top will be C. Now A is at top, now it is coming down. B is here, C is at down, C is going up, C is going up. But see the point B, where it is the point? It is keep on it center only. There is no change in its center of mass as well as the motion. Then we can say that it is a pure rotational motion on its axis. Okay, clear. And where the center of mass is existing, on the center where the it is existing. Okay, where it is traveling in a straight line. Are you getting? Right. So here the path of center of mass point, this point represents the motion of the body. What motion it is? Translational motion. Okay, straight line. Center of the body, the point which is moving in a straight line, then that point will be called as center of mass. Okay, it is in horizontal direction. Getting? Right. Now I am finding the center of mass for two particles. Let's consider x-axis, y-axis. So from the origin. Now I am about to find the two particles which are at different distances of masses m1 and m2, where the center of mass is existed in between these two, it will be existed. Okay, so let's consider these two are at a distance of r, and this will be from m1 to this center will be called as, just consider it as what can we consider? We can consider as r1, and this remaining you can consider as r2. From the center m1 is at a distance of, let's consider x1, m2 is at a distance of x2. Okay, got the point? M1 is at a distance of x1, m2 is at a distance of x2 from the origin. Okay, got the point? Right. So from here, so here there is a one rule is there. What is that means? The center of, we consider m1 and m2, if both masses are equal, center of mass is lies exactly at the center. If m1 is greater, it will comes towards the mirror, towards the m2. If m1 is greater, then center of mass comes towards the m1. So accordingly the weight it will be changes. Okay, got the point? Right. So now from here, if mass is more, distance will be less. That's what I told here. m1, m2, if it is exactly at center, both will be equal. If it is very near, then this distance is small, then this mass is more. So when mass is more, distance is less. Here mass is less, distance is more. So mass is inversely proportional to the radius, or radius is inversely proportional to the mass. It's not radius, distance. Distance is inversely proportional to the mass. So from this, m1 r1 equal to m2 r2 for two particles. For three particles, then that will be equal to m3 r3. Okay, we don't want that. We are considering two particles, so m1 r1 equal to m2 r2. So what about r1 here? So r1 will be from here to here x1, from here to here it is total is r, this is x1. Then what about this distance from here to here? Sorry, we want to find for only for r1. Only for r1, what will be the distance? R1 equal to this center what will be called? Center of mass, x, right? So from this, x center of mass will be equal to x1 plus r1, x1 plus r1. Okay, then from this point, from x2 equal to x center, I mean x center of mass plus r2, x center of mass plus r2. So from this r1 equal to xcm minus x1, r2 equal to x2 minus xcm. So r1, r2 going to be substituted in this equation. So if you substitute m1 xcm minus m1 x1 equal to m2 x2 minus m2 xcm. So take the center of masses to one side. Okay, so if you are taking center of masses to one side, then this is one dimensional only. Okay, so m1 xcm plus m2 xcm equal to m1 x1 plus m2 x2. So here xcm is there, you can take a constant. Xcm equal to m1 x1 plus m2 x2 by m1 plus m2, that was remaining, right? So from this also will be written as, this is the basic formula, this also will be written as, if this is for two particles, if there are n particles, m1 x1 plus m2 x2 plus and so on plus mn xn by m1 plus m2 plus and so on plus mn. This simply will be written as, for n particles, summation I equal to 1 to n mi xi by capital M. Capital M is the total mass. Okay, whatever the total mass we are going to get it. So mi xi by m. Okay, where m is the total mass. If you want, you can write that as mi also. Okay, it's not for ith particle, but it's a total mass. Let's consider capital M itself. So xm equal to sigma I equal to 1 to n mi xi by m, where sigma is nothing but summation, addition. Okay, clear, right? So next, see what is the x center of mass along x axis. This is m1 x1 plus m2 x2 by m1 plus m2. Got it? Then what about for y axis? If it is along y axis, m1 y1 plus m2 y2 by m1 plus m2. Similarly, ZCM for Z axis, m1 z1 plus m2 z2 by m1 plus m2. Okay, if you want to write that in terms of summations, then sigma x center of mass equal to summation I equal to 1 to n mi xi by m. For y axis it will be mi yi by m. For this will come as it is, ycm equal to sigma mi equal to 1 to n summation zcm equal to summation I equal to 1 to n mi zi by n. So this is for along x axis, y axis as well as for z axis. Okay, getting right. We'll see for two dimensionals. We'll see for two dimensional. So for two dimensions, same xcm, ycm, zcm, same it will come, xcm as well as only ycm. And what is the distance of the center of mass from the origin? So x center of mass, y center of mass. Let's consider axis, x axis, y axis. For suppose the point is here, this is the distance. That distance I don't know, but this is y center of mass, this is x center of mass for x. So how can we find this distance? The distance equal to root over x square plus y square. Like this we can find the distance also. Okay, right. Now we'll see the problems. Okay, see the first question. Find the position of center of mass of the system of three objects of mass 1 kg, 2 kg and 3 kg located at the corner of equilateral triangle. So change color. Here three objects, m1 1 kg, m2 2 kg, m3 3 kg located at the corner of a triangle. So this is the triangle which are the going to be corners. So let's consider this is m1, m2 and m3. Three are at the corners of the triangle. Okay, so that means from here it is y axis, this side it is along x axis. Okay, so now each side is 1 meter. Each side is 1 meter. So as it is a triangle, where it will be lies at the center. Okay, take 1 kg mass object at the origin and 2 kg, that's what I consider. 1 kg mass object at the origin and 2 kg along x axis. That means this is m2, this is m3. Okay, 2 kg is along x axis, remaining this will be the other particle. Okay, right. Now I want to find the where the center of mass is going to be lies. So what is along x center of mass? What is the formula? m1 x1 plus m2 x2 by m1 plus m2. So from this x center of mass, m1 is how much? 1 kg into x1. x1 means where this particle is. It is at the origin only. They told 1 kg mass object at origin. So there is no distance from the particle where we considered. That is 0 plus m2. M2 is how much? 2 kg into x2. x2 is how much? From here to here x2. That is 1 meter. Plus this third particle is also there no along x axis. It have at some distance from the x axis, from the origin along the side of x axis it is there. So how much distance? This is lies half. So this will be 1 by 2. So that is m3 plus m3 x3 by m3. Okay. So now 1 into 0 plus 2 into 1 plus m3. m3 is how much? 3 into x3 is 1 by 2 by 1 plus 2 plus 3. Then x center of mass equal to 2 plus 3 by 2 by 3, 4, 5, 6. So it is 4 plus 3 by 12. So it is 7 by 12. So on x-axis it is at a distance of 7 by 12. Then what about along y-axis? So YCM equal to same formula, m1 y1 plus m2 y2 plus m3 y3. How many particles are there? For all the particles we have to consider. So m1 plus m2 plus m3. So YCM equal to m1 is 1, y1 is 0 only, plus y2 means horizontal. This m2 object is it only on 0 axis of y. So it is also 0, 2 into 0 plus m3 is 3 into at a distance of how much distance from here? This is 1. So what about this? This is 1 by 2, this is 1 by 2, this is 1. So what about this? So that is 1 square equal to 1 by 2 whole square plus x square. So x square equal to 1 minus 1 by 4. So 4 minus 1, 4 minus 1, 3 by 4. So it is root over 3 by 2. This distance is root over 3 by 2. Okay. So it is root 3 by 2 by 1 plus 2 plus 3. So it is 6. So this is 0, this is 0. Remaining 3 into root 3 by 2 into 6. 2 ones are 2, sorry, 3 ones are 3, 2s are 2 2s are 4. So it is root 3 by 4. So y center of mass root 3 by 4. X center of mass 7 by 12. So there is no z particle, z direction it's not there. So x center of mass, y center of mass equal to 7 by 12 comma root 3 by 4. Okay, clear? So this is about this question. Got it? Fine. Okay, see the next question here. 4 particles of masses 1 kg, 2 kg, 3 kg are placed at the 4 vertices. 4 vertices of square. So it is one square. It is one square of A, B, C, D. You can consider any point, no objection, as they did not mention where the origin to be taken. Find the position of the center of mass of the particle. Generally, where the center of mass will be lies exactly at the center. Okay, I don't know, just I considered it is at the center. Okay, right. Even I don't know where it is, I want to find it out. So what is the formula? X center of mass equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 plus m3 plus m4. So this is for center of mass. So now from the center, let's consider what they mentioned. Side 1 meter, every side is 1 meter, every side is 1 meter. Okay, now from the center it is at a distance of how much? Okay, tell me this distance is total 1, then this is 1 by 2. From here to here this distance also 1 by 2. Then what will be this distance? That distance equal to root over 1 by 2 whole square plus 1 by 2 whole square. So D equal to root 2 into 1 by 2. So it simply you can write as root 2 by 2. Okay. Or 2 will be written as root 2 into root 2, root 2 gets cancelled. This also will be written as 1 by root 2. Okay, this is the distance. Actually, we don't want distance here right now. See for this. Let's consider this is an origin point. This is an origin point. So m1 A is 1 kg into x1, where this particle is at, I consider this is at rest now 0 plus m2, this is m2. M2 is what? 2 kg. At what distance from the origin? This is origin. From the origin at what distance it is? 1 meter. 1 plus m3. Where the m3 is? Here is an m3. So it is there on the x-axis as well as on y-axis. So on x-axis it is at a distance of 1 meter. On y-axis also it is at a distance of 1 meter. So on x-axis only we need how much distance it is? At a distance of 1 meter plus m4. M4 is how much? 4 kg into x4. X4 is, this is the one point where it is on the y-axis. On the x-axis it is 0 by 1 plus 2 plus 3 plus 4 each kgs. So 0, 2 into 1 2 plus 3 into 1 3 plus 4 into 0 0 by 4 3 7 8 9 10. Okay, so it is 5 by 10. That means 0 0.5 1s are 5 2s are 1 by 10. It's a 0.5 meters. Okay, similarly for YCM. Okay, as we found XCM, then we need to find the YCM also. So there M1, this is M1, M2, M3, M4, Y1, Y2, Y3, Y4. So here Y1 what is that? 0. Here Y2 also 0. Y3 1 meter. Y4 1 meter. So M1 0, M2 0, M3 is 3 kg, 3 kg into 1 plus M4 4 kg at a distance of 1 by 4 plus 3 plus 2 plus 1, it's a 10. So 3 plus 4, 7 by 10, it's nothing but 0.4 plus 3, right? Correct only, no? Is there any mistake? Correct only. So it is 0.7 meters. So on x-axis, x center of mass, it will be coordinates will be xy equal to 0.5 comma 0.7. Okay, clear?